I would like to present to you today how to write the equation of a straight line in any dimensional space. We have a disease called y equals mx plus b-itis. It only works in two dimensions. So let's look at how we can write the equation of a straight line in one dimension, in two dimensions, and three dimensions. And from that we can extend to 4, 5, 6, up to 11, 12, whatever number of dimensions that you want. So first, let's look at one dimension. To write the equation of a line, we need a point, and we need the direction of a line. Of course, in one direction, in one space there, the direction is either to the right or to the left. So let's get our 0 point here on the line, and then let's go over here to the point 1. Now if we take another point anywhere on this line, the equation for that point is x in vector form equals 1 plus t, where t is either positive or negative. So if I want to get to this point, I start here and I go in this direction so many units, which would be negative. If I want to get to this point, I start here and go over here so many units. So here is my equation of a line in one dimension. Find the x value by simply assuming a value of t. Now in two dimensions, things get a little bit tougher. If we have a point over here at 1, 2, and we're going to go in the direction of 3, 4, which means the slope of the line is 4/3, then to get to here, to point 1, 2, we want to get over here to a point which goes over 4 and up 3. So we want to go from here to here, and here is our point xy. So to get to the vector xy, which is this vector, we go to 1, 2, and then go over so many multiples of 3, 4. Giving us equations setting the vectors equal, x equals 1 plus 3t, and y equals 2 plus 4t. Which means x minus 1 over 3 equals t, and y minus 2 over 4 equals t. And since t equals t, we have x minus 1 over 3 equals y minus 2 over 4. Or y minus 2 equals 4/3 x minus 1, which is the point slope formula for the equation of a line going through this point in this direction. So here we have a very nice equation, and this can be solved to y equals mx plus b. Now in three dimensions, we've got a little bit of a problem, and this is where mx plus b falls down. So we have a point at 1, 2, 3, somewhere out here, and here is my vector going to the point 1, 2, 3. And then we're going to go out in the direction 4, 5, 6, so we'll be somewhere out here, and we're going to be at a point x, y, z. So to get from here to here, we go out to this point, and then we go out to this point in this direction. So my vector, x, y, z, this point, can be obtained by going to 1, 2, 3, and adding the direction 4, 5, 6. Which gives us the vector equation, x equals 1 plus, got to multiply by t, 4t, y equals 2 plus 5t, and z equals 3 plus 6t. Or x minus 1 over 4 equals t, y minus 2 over 5 equals t, and z minus 3 over 6 equals t. And since the t's are all equal, the equation of the three-dimensional line is x minus 1 over 4 equals y minus 2 over 5 equals z minus 3 over 6. The strange equation of a line in three space. two equalities. This is called the vector form of the line, and this is called the symmetric form of the line, and this is called the parametric form of the equation of a line. In 4 dimensions, the same thing comes here, except we'll have equals w minus k over its direction. Easy to find the equation of a line in any space. Forget mx plus b.